In this video, we will see another example of converting epsilon NFA into DFA. This is the epsilon NFA that we want to convert into DFA. Algorithm we have already discussed in last video. If you have any problem, you can refer that video. Link is given in description box. So first step is to compute epsilon closure of initial state. So epsilon closure of Q0 is Q0, Q1, Q2, Q3. Next, we need to find out the successor of epsilon closure of Q0. So we will do epsilon closure of delta Q0, Q1, Q2, Q3 on input alphabet A. So that is nothing but it's a union of all four transition functions, delta Q0 on A, delta Q1 on A, delta Q2 on A, and delta Q3 on A. So from transition table, we can see there is no transition from state Q0 on input A. There are two transitions from state Q1 on input A, that is Q0 and Q4. There is no transition from state Q2, and there is one transition from state Q3 on input A, which is Q4. So union of all those outputs will be Q0 and Q4, and we have to compute epsilon closure of Q0, Q4. That is equivalent to epsilon closure of Q0 union epsilon closure of Q4. So from diagram, we can simply find out that epsilon closure of Q0 is Q0, Q1, Q2, Q3, and epsilon closure of Q4 is Q3 and Q4. And union of that would be Q0, Q1, Q2, Q3, Q4. This is a new subset. We have not yet processed, so that we will add into the list L. So now this is our list Q0, Q1, Q2, Q3. This is under process. Okay, we have just started with that. And on input alphabet A, we got the output list Q0, Q1, Q2, Q3, Q4. So that is also added. Now let us compute the successor of Q0, Q1, Q2, Q3 for alphabet B, input alphabet B. So that is again union of all these four transition functions on input alphabet B. And from diagram, we can see that it's a Q2, phi, Q4, and phi. And this is equivalent to computing epsilon closure of Q2 union epsilon closure of Q4. And from transition diagram, we can see that epsilon closure of Q2 is Q2 only, and epsilon closure of Q4 is Q3, Q4. So ultimately that is Q2, Q3, Q4. This is also a new state. It is yet not processed. So we need to push it into the list. So Q0, Q1, Q2, Q3 is now processed. We have computed its successor for both the inputs A and B. And two more subsets are yet not processed. So we will select one by one sets from that, and we will compute the successors of them. So let us start with Q2, Q3, Q4. Order of processing is not important. Either we can select Q2, Q3, Q4, or we can select Q0, Q1, Q2, Q3, Q4. That is fine. We have to make sure that all sets are processed. Let us compute the successor of it. So that is nothing but epsilon closure of delta of Q2, Q3, Q4 on input alphabet A, which is equivalent to the union of delta functions on all three states for input alphabet A. And from diagram, it's phi, Q4, and phi. So that is nothing but epsilon closure of Q4, which is Q3, Q4. Again, it is a new state. It is not into the list. We need to add it into the list. Now we will compute epsilon closure of same set for input alphabet B now. And that will lead us just epsilon closure of Q4, which is Q3, Q4. It is already produced in previous step, so we don't need to re-add it. Okay, it is already there into the list. So now list looks like this. The first and third entries are already processed. The second and fourth we are yet to process. So we have to repeat the step 2 for both those subsets. So let us start with Q3, Q4. So that is equivalent to epsilon closure of delta Q3, Q4, A, which is equivalent to union of delta transition function of Q3 and Q4 on input A. Delta Q3, A is Q4, and delta Q4, A is phi, because there is no transition for input A from state Q4. And that will lead us to epsilon closure of Q4, which is Q3, Q4. And now we will compute it for alphabet B. So if we repeat the same process, then we have a phi as a output. So there is no new states are produced. Q3, Q4 was produced, but it is already into the list. So we don't need to add it again. So now three entries into the list are processed. They are shown in gray, and one which is shown in red is yet to process. So now we will generate the successor of Q0, Q1, Q2, Q3, Q4, which is equivalent to union of delta transition function of all those, and then we have to take epsilon closure of output of them. So that is just Q4, and epsilon closure of Q4 is Q3, Q4. Fine. So again, it is not a new state. It's already processed. So don't add it into the list. Now we'll compute the epsilon closure of this on input alphabet B. And that is union of all these transition functions. And that is equivalent to epsilon closure of Q2 union epsilon closure of Q4, which is Q2, Q3, Q4. And again, that state is also already there into the list. So all four sets in list are processed. That means we have to stop here. Now, whatever states and transitions we have generated, based on that, we can draw DFA like this. That initially from Q0, Q1, Q2, Q3, when we read A, it is going to Q0, Q1, Q2, Q3, Q4, and on reading B, it is going to Q2, Q3, Q4. Fine. So likewise, we can add subsequent arcs, and finally we can produce the desired DFA. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.